Hi, welcome to a quick run-through of some of the adaptive input experience concepts that we here at Microsoft Hardware have come up with as we worked on what it means to build interactive input devices for productivity scenarios. My name is Håkon Strande. Yep, it's Norwegian. I'm a program manager here at Microsoft, and I was part of the team who built the prototypes that you will be able to use as part of the UIST contest. All of us here at Microsoft hope that you will have fun with these and come up with much better demos than those we put together to get your imagination going. The form factor I have here is what we'll be using in the contest, and we named it the Adaptive Keyboard. It's really just a tactile keyboard with a display underneath it, programmable display key tops, and a touch display area above the key region. I'll show you some ideas that we had about what familiar applications may choose to do when they can extend their user experience and interaction model to the horizontal plane where your hands naturally rest most of the time in productivity scenarios. The idea was to see if touch and dynamic context-based controls on an input device could increase productivity, help users discover new features, become advanced users more quickly, and maybe also delight a little bit. Keep in mind that all these examples are purely exploratory and does not infer any actual Microsoft product feature, past, present, or future. In our first scenario, the OS desktop is extending its experience to the adaptive keyboard by showing me the regular QWERTY layout and using the touch region to show me some of my recent documents and applications. I can browse through my previous work and easily reach out and touch a document that I want to open up. In this case, the PowerPoint slides that I've been working on. You'll notice that when the application takes focus on the monitor, the content on the keyboard also changed. What you'll see in this demo, and what we hope you will experiment with, is the ability to dynamically change the input device content based on user context within a set of user application tasks. Not simply change the keyboard layout to a new static set of icons just because a new app process came into focus. At this stage, we chose to show icons of things that the user can insert into the slide on the keys instead of letters, since the user context is not a text box. The function key row has easily identifiable icons for the functions on each key. Now I don't have to remember that F4 equals insert charts. I can actually see it as long as I know my app's icons. We are curious about the productivity impact and other benefits of a slightly more recognition-based interaction model versus a purely recall-based one. We imagined that PowerPoint may choose to use the adaptive keyboard to show the slides in my deck on the touch display area of the adaptive keyboard, so I can easily and comfortably move through them with my finger. I'm going to navigate through my slides, similar to how I found the slide deck previously, and find a place to insert my new slide. You can imagine that some of these interactions could save you some time when you're navigating UI with your mouse. Limit the miles your mouse cursor travel every day, so to speak. Inserting a slide could perhaps be accomplished by resting my finger between two slides like this. And why not show the various layout options right there for me to quickly reach out and select. Now that I have my new slide, I want to add some content, and we imagine that dynamic key tops could help a great deal by limiting the need to navigate complex second-tier UI and drop-down menus with your mouse. In this case, I want to insert a chart, so I press the function key that looks like a chart, and the entire keyboard region changes to show me all the different chart types that PowerPoint supports. Since I'm fond of pie, I'll insert a pie chart. Now I could move my hand to the mouse and start looking for a suitable animation for the pie chart, or if I recognize the animations icon on the function key row, I press it, and the entire keyboard region changes now to show me the many fun animations PowerPoint supports. I select one I want quickly, without moving my hands or traveling with my cursor all over the screen. Same thing when I need to author my speaker notes. I can activate speaker note entry through a soft key affordance, rather than moving my right hand to the mouse, finding the mouse pointer on the screen, moving it across the screen down to the speaker note sub-window, clicking there, and then moving my hand back. Now that I'm in the text entry field, I do have QWERTY back on my keys. And you can imagine many common sense features from the dynamic key tops, like showing capitalized letters and highlighting symbols on the numeric keys when the shift modifier key is pressed. When the control modifier key is down, the application could show the user the names or icons of the various keyboard commands it supports. The Windows key actually has some cool features hidden behind it, and now you could see those appear in the keys when holding the Windows key down. Now I'm sending this presentation to my friend Joshua. I can see a function key with an email icon on it, and pressing it takes me to Outlook. When Outlook comes into focus on the desktop, you'll notice that in our demo we imagine that Outlook may choose to extend its experience to the adaptive keyboard as well. And maybe you can see your most recent contacts here in the touch region. I got some really good looking friends and colleagues, and I'll see if I can find Joshua by I could scroll back and forth, or I could just type in the first letters in his name. There he is. And off the presentation goes to Joshua's critical eyes. Now, of course, he'll find something to complain about. So he opens a video call to me. When this happens today, typically some UI toast from the communication application pops up on your screen and takes focus away from what you're doing, interrupts your flow, and literally takes focus away from your input devices as well. You got to take an action on it. In this demo, we show that such applications could make use of devices like this adaptive keyboard to notify and enable quick reach actions that minimizes interruption of my current workflow. In this case, Imagine Communicator provides the notification of the video call and a few possible options like these for what to do with the call on the touch display of the adaptive device. I can send this to my mobile device or to voicemail, but I'm going to take this call since I'm still thinking about the presentation I just sent to Joshua. And here he is talking away about all the little nits and typos he found in my slides. What a character. I'm going to end the call and show you the last part of the demo. Now, I've shown some scenarios where the application I'm working in is using the adaptive device to extend its experience. There's also a multitasking aspect to these types of devices, and you can imagine something as simple as browsing a selection of my music collection while I write my thesis or some boring weekly report. In this case, I'm going to use the touch display part of this horizontal input device to navigate to my recent applications and to open up Visual Studio. There it is. Now, when Visual Studio is in focus, the device takes on a role as an extension of the Visual Studio application experience. I can see the different solutions and projects I'm working on. The keyboard region is simply showing me the possible choices by showing icons on the keys that match those of possible choices in the Team Explorer sub-window. A flashing notification on the touch display tells me that I got a new bug assigned to me, and I'll quickly reach out and open it by expanding the list and touching the relevant bug in the list. When Visual Studio opens up the bug, we imagine that the dynamic input device also changes to help the user in this new context. I can see the different files associated with the solution that the bug description covers, and I have various tabs that correspond to different tasks, perhaps. As I'm typing away in the bug description, probably telling the tester that their bug is bogus, I need to move my focus over to another sub-window within the application. Usually this requires me to move my hand to the mouse, find the mouse pointer on the screen with my eyes, move the pointer to a non-hit area of the sub-window, and then move my hand back to the keyboard again. We were thinking the adaptive keyboard's touch region could be used to simply reach out and flick in sort of a window management area to move focus from one sub-window to the next. While I'm in the Team Explorer window, I see the various solutions again in the touch display. And I'll open up my solution to start working. I have frequently used tools available in the touch display, ideal for a quick reach and activate interaction model. I'll bring up the code snippet I'm working on by navigating the tabs in the touch display. And as a final idea for what such a horizontal display input device, the adaptive keyboard, could be used for, I'm going to double tap in the window management area I showed you earlier to go to full screen and back again. And that's it. We hope this quick demo gave you some ideas of the possibilities these kinds of devices provide. And now it's your turn. Good luck.